OCR Computing Revision Notes. Feel free to pause the video or make notes. I would advise that you download this video as an MP3 file and listen to it whenever you can. Make sure you understand what is being said. This is the most important thing. Computer systems. A computer is an electronic programmable data processing machine. A system is a collection of parts that work together for some defined purpose. A computer system is a collection of hardware and software that works together to achieve some data processing task. Systems receive inputs from the outside. They process these inputs and they output the results of the processing. A system is separated from the outside world by a system boundary, also known as interfaces. Most aspects of our lives are affected by computer systems, for example, forms of communication, ATMs, and robotic machinery. Types of computer systems. General purpose systems are personal computers such as laptops, tablets, and smartphones designed to perform multiple tasks such as loading a variety of apps for different purposes. Dedicated systems are used to perform a single function or set of functions, for example, a ticket vending machine. Control systems are computer systems that control machinery and do not produce any outputs for humans. They are mainly used in manufacturing processes and also personal gadgets. Industrial robots are important as control systems. Embedded systems are computer systems which are part of a larger system. They are usually control systems. They include portable devices such as sat-navs, digital watches, MP3 players, but can also be used as traffic lights. Embedded systems can either be very simple or highly complex. Expert systems are computer systems designed to behave like a human expert. They have three components: a knowledge base, an inference engine, and an interface. They are commonly used for diagnosing diseases, finding faults in machinery. Management information systems brings information from all parts of an organization so that managers can make sensible decisions. They cover technology, data, and people. They produce regular reports based on the organization's data. Reliability. Computers are central to most day-to-day activities. They play a central part in many life or death situations, for example, aircraft navigation control and railway signaling. Medical computer systems include activities such as record keeping, DNA sequencing, and diagnosing of diseases. Reliability is expected when new computer systems are commissioned. Mistakes in the production can lead to expensive errors, data loss, and compromised privacy. Reliability is also referred to data integrity. This relates to data being accurate and consistent throughout its life. Data integrity also means that stored data reflects real-world reality. Data integrity can be compromised by human errors when data is entered, software bugs, viruses and malware, and hardware malfunctions. To reduce risks to data, backing up of data is done regularly, and the use of using error detection and correction software when transmitting data. Reliability is improved through testing, as it is designed to uncover any errors. However, testing can never be completed because the software is too complex. Testing is expensive, and testing is time-consuming. There are many pathways through most modern systems, so usually a lot of errors in extensively tested systems. Standards. Standards refer to conventions and rules. They are normally defined by a responsible organization. There are various categories of standards. And computing standards exist for data formats, operating systems, programming languages. Standards are important because they enable equipment from different manufacturers to work together, make learning new systems easier, and minimize waste. De facto standards develop over time because of common usage. They become important because they ensure that files and systems can be used by anyone, for example Microsoft Word. De jure standards are the de facto standards that have become so universally accepted that they have to be obeyed by or communication is impossible, for example PDF. Proprietary standards are owned by organizations and assure compatibility between the company's products. They are used to reduce competition from rival products by locking users into their own software. Industry standards are set by recognized non-commercial organizations. Open standards are publicly available, produced collaboratively, available free of charge or at a small cost. They ensure that access to resources is not dependent upon a single application or a particular hardware platform. Examples are HTML, TCP/IP, or HTTP. Ethical and legal issues. Computer systems can be used for good or bad. Making choices between doing good and doing bad is a matter of ethics. An ethical act is one that is morally right. A legal act is one that does not break any laws. Widespread computers have produced new legal and ethical challenges. They are to do with privacy, data security, copyright, and fair charging for services. Data protection laws include provisions that organizations must allow people to view the data held about them, correct information when requested, and not use data in any way that may potentially cause damage or distress. There are other laws that make it legal to access or modify unauthorized computer material. Nowadays, there are numerous examples of cybercrime, which are crimes committed with the aid of computers. Environmental issues. Obsolete computers have to be disposed of. They contain toxic materials such as lead, cadmium, beryllium, and flame retardants. Electronic waste is often shipped to developing countries and dumped in landfills, where toxic chemicals can leach out into the soil. Old computers contain a lot of plastics, and when they are burnt, they produce dangerous chemicals such as dioxins. Computers use energy, and so data centers use lots of energy. Much of this energy is used to run air-conditioned systems to cool the computers. Ways to reduce energy by computer systems are to use virtual servers that reduce the number of physical servers in a data center, and to use solid-state storage that use less energy than rotating disk drivers. Computer hardware. Hardware is the term that describes the physical components of a computer system. Hardware components include input, output, and storage and processing devices. The Central Processing Unit. The Central Processing Unit, CPU, carries out all the processing in a computer. The Arithmetic and Logic Unit, ALU, carries out all of the arithmetic and logical operations. The control unit uses electrical signals to control the flow of data within the CPU. The fetch-execute cycle is 1. Fetch the instruction from memory. 2. Decode the instruction to find out what processing to do. And 3. Execute the instruction. The boot sequence is a sequence of processes that contains all the information and instructions to get the computer up and running. It contains the bootloader, which is a program that starts this sequence when the computer is switched on. Control is handed to the operating system after the boot sequence is finished to provide programs for the CPU to process. The speed at which a CPU processes data depends on the CPU speed, which is the processor speed, the cache memory, and the number of processor cores. The speed of the fetch-execute cycle is determined by an electronic clock chip. This is measured in cycles per second, known as hertz. Processor speeds are measured in gigahertz. The CPU cannot access main memory at the same speed as the processor clock chip. Transferring data from main memory causes delays. Cache memory has access times similar to the CPU, but is very expensive. Data that is in use is transferred to cache memory to make access to it faster. Multi-core processors use CPUs by working together. The CPUs can all fetch, decode, and execute instructions at the same time. The advantage is that more data is processed simultaneously. The disadvantage is that more complicated operating systems are needed to manage them. Memory. Random access memory, also known as RAM, is volatile, which means data is lost when the power is turned off, can be accessed and changed by the computer at any time, stores program and data being used by the computer, contains the opening system, and large, which means 4 GB or more in a typical computer. Read-only memory, ROM, which is non-volatile, which means data is retained when the power is turned off, programmed during computer manufacture, stores instructions and data required to start up the computer, contains the boot program, and is small, 1 or 2 megabytes required for the boot program. Virtual memory is part of the hard drive used as an extension to RAM. It is used when the computer does not have enough RAM to hold all the data and programs required. Data passes between RAM and virtual memory. Access to virtual memory is slower than to RAM. Adding more RAM reduces the use of virtual memory and improves the performance of the computer. Flash memory is a type of ROM that can be rewritten. It is used as a portable medium for storing and transferring data. Binary logic. All computers work in binary and use simple logic circuits to make calculations. There are 3 main logic gates. Not logic gate. When the input is 0, the output is 1. When the input is 1, the output is 0. And logic gate. When the input of A and B are both 0, the output is 0. When the input of A is 0 and the input of B is 1, the output is 0. When the input of A is 1, the input of B is 0, the output will be 0. If the input and input of A and B are both 1, the output will be 1. Or logic gate. If the input of A and B are 0, the output will be 0. If the input of A is 0, the input of B is 1, then the output will be 1. And if the input of A is 1, the input of B is 0, then the output will be 1. If the input of A and B are both 1, then the output will also be 1. Input and output devices. Computers are used to process data simply in order to provide us with the required output. A computer is of little value if it cannot accept inputs and provide outputs. There are many ways data can be input to or output from a computer. Input devices are keyboards, mouse controllers, microphones, and barcode scanners. Output devices are monitors, inkjet printers, and speakers. Secondary storage. Secondary storage is needed to store data and programs when the power is switched off. A magnetic hard disk stores the operating system, installed programs, and user data. Hard disks are reliable, high capacity, and low cost. An optical disk is excellent for transferring files or distributing software. Optical disks are good capacity low cost, and lightweight and portable. A CD stores 700 megabytes and a DVD stores 4.7 gigabytes. Flash memory consumes little power. It is good capacity with less maximum capacity of a hard disk. It is used in handheld devices, but more expensive than a hard disk. Considerations when selecting storage are capacity, speed, portability, durability, and reliability. Software. Software is a term given to the programs you run on our computers. The programs are the stored sets of instructions that are given to the processor to carry out. Software refers to the data that is used by the program. Dedicated systems have software installed on a chip of some sort. This software is specific to the job and is only changed when updated. Multi-purpose computers such as laptops, tablets, and smartphones regularly run different programs according to the wishes of the user. Multi-purpose computers store their software on a secondary storage medium such as a hard disk, memory stick, and an SD card. The programs are loaded into RAM when required, and instructions are sent out one at a time to the processor for decoding and execution. Different types of software include system software, which controls the hardware, application software, which handles the real-world jobs that users want to do, and utility software, which has limited functionality and is used to maintain computer systems. Software is usually produced using a programming language and some by an automatic software generator. System software. System software is the software that controls the hardware. Without system software, application programmers would have to take into account the precise movement of data between locations. System software takes care of this. System software acts as an intermediary between the application and the hardware. It hides the complexities of the hardware from the user and the application programmer. It allows the user to operate the computer without having to write programs. The main part of system software is the operating system. The operating system is a set of programs that controls the hardware and lets users and applications work with the computer. At its heart is the kernel, which is the part of the operating system that actually makes the hardware do things. User interface software. An operating system must provide a way for the user to control and interact with the computer. The user interface is the boundary between the human user and the machine. The interface lets the user give commands, ask questions, and displays a response. A command line interface requires the user to type commands. The commands are translated by a command interpreter into signals that the computer can understand. You can also group commands together in a shell script to carry out maintenance jobs automatically. A shell is software that a user needs to communicate with the kernel. A graphical user interface, GUI, uses icons to represent resources, files, programs, and actions. GUIs are a useful way to interact with a computer because they are intuitive, easy to use, and no commands need to be learnt. The GUI interacts with the kernel and allows access to everyday features. Memory management. Operating systems have to decide what goes where in memory. They have to make sure that memory is used effectively and important data is not overwritten during the running of a program. Memory is divided into pages. When a program is executed, it's called a process. The process is loaded into a vacant page, whilst the operating system keeps a track of this and keeps it from being overwritten by other processes. When there are more jobs than space in the memory to hold them, the operating system swaps jobs in and out of memory using virtual memory. Virtual memory uses secondary storage to hold parts of a program that are not currently needed. A large program may take up too much memory, so it is divided into modules. The modules are stored separately on secondary storage. When a module is needed, it is swapped into memory and run as a process. A file is a named store of data on a secondary storage medium. Files can be data files, program files, or configuration files. The operating system keeps track of all the files in the system. These are stored on secondary storage and copied into main memory when needed. Just as with main memory, secondary storage is also divided into segments. Files are often larger than the size of a segment, so they are split into blocks across many segments. If a file is split across many locations, it takes longer to read and write. Each block contains pointers about the location of the next block, so the operating system can follow the pointers to recover the file. After a while, access to the file is slowed down. A process called defragmentation can be used to tidy up the disk or other mediums so that parts of the files are removed to be stored next to each other. The operating system has to take control of all the inputs and outputs for a system. The manufacturers of equipment provide device drivers. A device driver is software that allows the operating system to communicate with the device, allows devices to operate independently of each other, and creates an interface so that the programmers do not need to be concerned about the peculiarities of the device. Most all-purpose systems commonly have several programs loaded into memory at the same time. This is called multi-programming. It seems to the user that when many processes are running at the same time, it is multitasking. A multi-programming operating system must make sure that the CPU is in use as much of the time as possible, tries to speed up the operation of all tasks, and shares resources fairly between tasks. When there are several processors sharing the single processor, the operating system uses a scheduler in order to allocate time. The allocation is made according to a policy. This policy might be shortest job first, all jobs get equal time, or first come first serve, or even important jobs first. Files and directories. Operating systems organize files on secondary storage. Most use hierarchical systems. Files are stored in directories. Directories include subdirectories. A directory is a logical grouping of files. In Windows systems, directories are called folders. Directories are useful because they make it easy for a human user to allocate related files and allow repeated use of the same file name in different locations. Some file systems use file extensions. These are part of the file name that indicate what type of file it is. In Windows systems, the file extension is given after the dot. For example, doc, PDF, HTML, JPEG, and MP3. Files can be given different attributes which provide extra information about the file, such as the creator of the file, size of the file, last modified, and who can view it. Security. Viruses are programs that attach themselves to legitimate programs. They often have a payload which is designed to do things such as damage themselves, take control of a computer, retrieve confidential data. Some viruses have no payload but still cause damage. Operating systems usually allow authentication of users. This means they can be set up to check that users are who they say they are. This normally involves having an ID and a password. Privileges are the rights assigned to users and groups. They may include features such as whether for a particular file the user can read, write, and execute. Some files are encrypted. They are transformed in such a way that an unauthorized person cannot understand them. It is common for user passwords to be stored in an encrypted state. Programming software. Editors or text editors are like cut-down word processors. They allow text files to be created, saved, read, and changed. They are particularly used for writing the source code of programs and editing configuration files. All operating systems come with a variety of editors as standard. Examples of editors are Notepad in Windows and Nano in Unix equivalents. Linkers combine modules of object code, compiled program code, into a single executable program. Interpreters convert typed commands into the machine instructions that the processor understands. Applications and utilities. Applications are the programs that people use to do real-world jobs. There are huge numbers of them, and they include such examples as word processors, autopilots, traffic light controls, hotel booking systems, and engine management systems. Utilities or software tools that help make maintaining the system easier. Most operating systems come bundled with loads of utilities. Here are some common ones: antivirus utilities, system maintenance utilities, disk organization utilities. Software procurement. Software can be obtained from various sources. System managers must make choices so that their organization gets systems as required that users will want to use at a reasonable price and of an acceptable quality. Custom written software is a software specially commissioned for a particular customer. Advantages are it should have exactly the features required, and the developer can be contacted to solve issues. Disadvantages are it may not have been extensively tested and may have taken a long time to develop. Off-the-shelf software can be bought from a supplier already boxed up and ready to install, for example Microsoft Office. Advantages are it is ready immediately and has probably been extensively tested. Disadvantages are it probably won't be exactly what the customer needs, and training may be required for the user. Open source software is software that has been placed in the public domain by the programmers. They often produce software to improve their skills or for the public good. For example, Linux and Firefox. Advantages are it may be free of charge and can be altered because the source code is available. Disadvantages are there are no maintenance contracts and there is no one to contact if there are any problems. Proprietary software is software that is developed for profit by a company. The source code is retained as a valuable trade secret. Only the compiled code is released, and the users need to buy a license to use it. Advantages are updates are scheduled regularly, and there is someone to go to if there are any problems. Disadvantages are it can be expensive and may be inflexible to users' needs. Numbers. Modern computers work in binary because it is easy to represent two states in simple electronic circuits. All data and instructions are in binary. Binary is a number system with just two symbols, 0 and 1. Each digit is a binary number, which is called a bit, binary digit. The binary number system works like a familiar base 10 system, but uses multiples of 2 instead for the column values. In binary, the column values are 2, 4, 8, 16, 32, 64, and 128. If we want to know what the binary number 10110 is in denary, we put the numbers into this table starting from right, going to left, and add together the column values where there is a 1. 16 plus 4 plus 2 equals 22, which is the denary value for 10110. A group of 8 binary digits or bits is called a byte. As in base 10, we have names for key values based on 2 to the power of 10, or 100 and 1024 bytes. 8 bits equals 1 byte, 1024 bytes equals 1 kilobyte, 1024 kilobytes equals 1 megabyte, 1024 megabytes equals 1 gigabyte, and over 1024 gigabytes equals 1 terabyte. Half a byte, which is 4 bits, is generally called a nibble. Adding in binary uses the same approach as in base 10. We add the values, and if the value is larger than the column will hold, we carry a value to the next column. Rules for adding are 1 plus 1 equals 10, 0 plus 1 plus 1 equals 10, 1 plus 0 plus 1 equals 10, 1 plus 1 plus 1 equals 11, and 0 plus 1 equals 1. If a computer uses storage values that are 8 bits long and we add together 11000010 and 10111010, this happens. We need a 9th binary digit. If our computer has only 8 bits to store a value, then this last bit will be lost. This is called an overflow. The result of the addition is too big to fit in the available space. Hexadecimal numbers. Large binary numbers are difficult to remember, and programmers want something that is easily converted from binary, but also easy to remember or recognize. An 8-bit byte splits easily into 4-bit nibbles. In 4 bits, the largest value we can store is 111, or 8 plus 4 plus 2 plus 1, which is 15. If we are to represent each nibble using a single digit, we need more symbols. In hexadecimal, we use the letters A to F to represent the base 10 numbers up to 15. Converting from hex to denary uses column values. For example, 27 hex in denary is 32 plus 7 equals 39 in denary. Another example is BD hex into denary is 176 plus 13 equals 189 in denary. To convert from denary to hexadecimal, we can use this method. Let's take the number 197 for example. Find out how many 16s fully fit into 197 by dividing it by 16, which is 12. The number 12 in hexadecimal is assigned to the letter C. All you have to do now is put the letter and the remainder together, which is C5. 197 in denary is C5 in hexadecimal. To convert from binary to hexadecimal, we simply split the binary into 2 nibbles and convert each one to get the hexadecimal equivalent. For example, 101011 to hexadecimal is. So 101011 is A3 in hexadecimal. To convert from hexadecimal to binary, we simply replace each hex digit with the equivalent binary nibble. For example, let's convert BD to a binary number. B equals 11 in denary and 1011 in binary. D equals 13 in denary and 1101 in binary. BD in hex is 1011101 in binary. Characters. All the symbols displayed by a computer are represented by a code. The computer looks up the symbol matching the code from a list of codes and their associated characters. This is called a character set for the computer, which is stored in binary. The number of bits used to store the code determines how many characters or symbols can be used. American Standards for Information Interchange uses 7 bits, which provide 127 characters or symbols, plus the null character, which is 128 in total. However, Extended American Standards use 8 bits, which store 256 characters or symbols. Unicode uses 16 bits, providing over 65,000 possibilities, or 32 bits, providing over 4 billion possibilities. Unicode can provide a character set for a computer that includes a wide range of specialist symbols. Unicode keeps the same assignment of codes for the original 127 character. So, American standards for information interchange can be considered for a subset of Unicode. Images. Images are stored in binary on a computer. The computer is able to work out how to turn these binary values into the image because the file with the binary data contains metadata, data about the data. The height and width of an image is measured in pixels. A pixel is one dot in the image. The number of bits we use for a pixel determines how many colors each dot can represent. 1 bit can represent just 2 colors. 2 bits can represent 4 colors. 8 bits can represent 256 colors. 16 bits can represent 65,536 colors. The more bits per pixel, BPP, the greater the color depth and the more bits we need to store the data. 16 BPP is called high color. 24 BPP is called true color. The resolution is the number of pixels per unit. For example, the number of pixels per inch. The more pixels per inch, the more data needs to be stored, and the larger the file needed to store the image. If a bitmapped image is displayed enlarged on the screen, the image size does not change. The dots just get bigger and the image becomes pixelated. Sound. Sound files are described by metadata to make sure the computer can interpret the data accurately. The data stored includes the audio codec and the sample rate. Sound is an analog, continuously varying form, so sound needs to be digitally sampled to be transferred to a computer. The sample interval is used to describe the sample rate and is the time between samples being taken. The higher the sample interval, the lower the sample rate. When sound is sampled at a low rate, very few samples are taken. A small file size is required and there is a poor match to the original sound and the sampled. When sound is sampled at a higher rate, many more samples are taken. There is a good match between the original sound and the sampled sound. A large file size is required. The bit rate is the amount of space to store each second of the sample. A high bit rate means more accurate sampling at each point, which gives better quality, and more data needs to be stored, which needs a larger file size. Instructions. When a computer is instructed to run a program, it is directed to a specific location in memory that contains the first instruction in the program. The CPU fetches the instruction and decodes it in order to find out what to do next. The instruction is in 2 parts: the operator, the instruction part, and the operand, the data part. In the first location, it contains an 8-bit binary code. It will be split into 2 parts. 1001111 would be 1001 and 1011. The operator binary code, which is the left side of the binary code, represents an operation. The operand binary code, which is the right side of the binary code, represents the data that the operator uses. The accumulator is a special register in the CPU used to store the results. The CPU cannot tell the difference between data and instructions, and so it just deals with what it expects to find. Databases. A database is a persistent, organized store of data on a computer system. Persistent means it is saved on secondary storage. Organized means databases have a structure so that they can easily be processed. Organizations depend on the databases in order to operate properly, otherwise they would not be able to function without them. Databases need to be accurate, up-to-date, and protected from those who do not have access. Database administrators protect their database against errors, loss, insufficient data, and unauthorized access. Errors in databases can result in embarrassment, final loss, or life and death situations. Data security and data integrity. Data security refers to keeping data safe. It is important that data is not lost. Data can be lost because of a catastrophe such as a fire or flood, an accident such as an employee deleting data, and a malicious action such as an intruder. Data is protected by making regular backups, having a mirror database, restricting access, and storing backups. Data integrity means that the data reflects reality. It implies that the data is correct and fit for purpose. Data integrity can be maximized by suitable validation and software that prevents inconsistent states. Validation is a process of checking data when it is input. Validation is carried out by software. It checks that the data conforms to certain rules. Verification is checking that the data entered is correct. Databases are everywhere. Databases are used in telephone companies, schools, banks, shops, hospitals, and in governments. Database administrators create and look after databases. They make use of database application software. Databases help organizations to process information. They make data easy to access, search, sort, group, copy, and protect. A subset of the data in a database is called a view. Making suitable views for each staff member increases the efficiency of using the database and reduces risks. Standard operations on databases are sometimes listed under the term CRUD. This is an easy way to remember the basic things that most users need to do in a database: create, read, update, and delete. Data matching compares different databases to look for a particular relationship. Data mining is a process that looks in many different unrelated databases. Data models. Databases are organized according to a model. A model is a data structure that attempts to represent reality in such a way that it is useful to the owner of the database. The simplest model is a flat file database. This is just rows and columns such as would be suitable for an address book. Each row is called a record, and each column is called a field. It is easy to set up a flat file using a spreadsheet. Flat file databases are very limited. One of their main problems is that data might be repeated unnecessarily. This is called data redundancy. A hierarchical model is useful when making an inventory. Relational databases are the most useful model and the most common type of database. They store their data in separate tables. The tables are linked together so that related data can easily be extracted. Each table in a relational database contains data about an entity. An entity is something in real life about which we can store data. Well-designed relational databases separate data so that entities are linked in one-to-many relationships. A database management system, DBMS, is a software that looks after a database and allows database administrators to create database applications, protect data, and keep data consistent. The DMBS acts as a go-between, connecting applications to the underlying data. It is important to separate applications from the data so that programmers do not have to worry about applications damaging existing structures. New applications can be written without restructuring the data, and data can be more easily shared between applications. When a change takes place in a database, it is called a transaction. Transactions must not damage the integrity of a database. Most commercial databases are multi-user. Many people need to access them at the same time, which can cause conflicts. To avoid this, Most DBMSs use record locking. This means that if one user has an opened record for writing, other users can only view until the transaction is committed. Common tools provided by DBMS. Most database management systems have a set of standard tools. Tables are the structures where data is stored. The DBMS provides tools for creating and modifying tables. Each table contains just about one entity. A row is equivalent to a record. Each row in the table is made up in the same way. Each table has a primary key. A primary key uniquely identifies a record. A primary key can be one field, usually a reference of some sort. Each field, column, has to be particular data type. Linking tables is when relational databases are linked together. The primary key of one table can be linked to the foreign key of another table. This allows data to be stored once only. When a field is set up, the designer must choose what data type it will be. This makes it easier for the software to validate and process the data. Data types include number currency, text, date or time, yes or no. Forms provide a friendly user interface. Data can be input into tables from forms, or selected data can be output to the screen in a form. Reports are outputs from a database. They can be set up to summarize, group, and select data. Some DBMSs include graphing features so that the application programmers can simply call them up to display data rather than having to write their own display routines. A query is used to extract a subset of the data in the database. Queries can combine data from more than one table and present data in whatever order is required. There are two ways queries can be created. Query by example uses a graphical interface that lets the user assemble the fields and conditions required for a query. Structured query language makes it possible to write programs that extract the data required. Query languages provide operators to check conditions before selecting data to display. Commonly used comparisons are and or. The AND operator checks that two conditions are true, then selects the data that matches these conditions. The OR operator checks that either of the two conditions is true, then selects the data that matches these conditions. A database module is a unit of software that takes care of some particular functionality of a database. Some DBMSs allow you to add such capabilities to a database by writing program code in a language supplied with the DBMS. Referential integrity is a feature of a DBMS that doesn't allow changes to be made that are logically impossible. Computer communications and networking. A network is a collection of connected computers plus their peripherals. Each device on the network is called a node. Most general-purpose computers are networked in order to take advantage of this easy communication. A LAN is a local area network. Most organizations and some individuals have LANs. A LAN is confined to one site and connected using equipment owned by the organization. Networking computers in a LAN has many advantages. Expensive peripherals can be shared, users can communicate with each other, and computers are easily updated. Disadvantages are network problems might affect all users, and security might be a problem because data is accessible from many places. A WAN is a wide area network. It covers a large geographical area. The ultimate WAN is the internet. WANs often connect LANs together and allow businesses to function from any location. Network hardware. Special hardware is needed to connect computers. This is to do with creating, receiving, and routing electrical signals. Each device on a network needs a network interface controller, NIC, also known as a LAN adapter. This is built into the motherboard of newer computers. LANs make use of a network standard called Ethernet. so it makes sense to include an adapter as part of the computer so that it will work everywhere. Every NIC has a unique media access control, MAC, address stored in ROM. This allows each node on a network to be identified. The connection between devices on most LANs are made with copper cables, known as unshielded twisted pair, UTP, for longer distances and use outside. Fiber optic cables are often chosen. They can carry more signals and are cheaper. Hubs are hardware devices that connect many network devices together, making them into a single network segment, which is a defined part of a network. They have a number of input and output ports which connect to each other. A signal arriving at one is transmitted to all others. Switches connect network segments or devices. They can act as bridges to connect networks together to make them function as one. A switch transmits a message only to the device intended instead of all the connections. Wireless access points allow connections to LANs without physical cables using standards such as Wi-Fi. Access points are often connected to a router. New nodes can be added without the need of cables. They introduce security risks which have to deal with the use of encryption, hiding broadcast identities and allowing access to only certain MAC addresses. Routers receive data in the form of packets and forwards them to their destination, which is often another router. Routers direct traffic through large networks, notably the internet. Small routers are used in a home to connect individual computers to the Internet Service Provider, ISP. Types of network. A client server is when one or more servers provide services to many client machines where the users work. Servers are computers that are set up to handle network functions. They are typically high-end computers that have enough storage and speed to serve the needs of many connected computers. Typical servers include database servers, file servers, mail servers, print servers, web servers, and game servers. The advantage of a client server is that the network functions are handled by dedicated machines. The clients can provide for the immediate needs of the users. In a peer-to-peer network, all computers are equal. Each computer serves the needs of the user as well as carrying out networking functions. Peer-to-peer networks are easy to set up, but maintenance is more difficult than the client-server network. Security is poor, and they tend to be slow because of the amount of multitasking. The peer-to-peer model is useful on the internet where files can be shared directly between users without the need to go through web servers. Network topologies. Topology refers to the layout of the network components, the cabling and the position of the nodes. In a bus topology, the computers and other devices are attached to a single backbone. A terminator is attached to at each end to prevent reflection of signals. Signals travel in either direction. Advantages are, it is easy to set up and is cheap. Disadvantages are, problems with the backbone can bring the whole network down. Limited distance can be covered, and many data collisions slow the network down. In a star topology, client machines are connected to a central switch or hub, which is usually in turn connected to one or more servers. Signals travel in either direction. Advantages are, robust problems with the connection do not affect the whole network, and there are fewer data collisions than bus, so it's faster. Disadvantages are, needs more expertise to maintain, can be expensive to set up because more building work is needed, and more network hardware and software is needed. In a ring topology, data passes through each node, carried in data units called tokens. Traffic is one way which prevents collisions. Advantages are, very fast, no collisions. Disadvantages are, problems with the backbone can bring the whole network down, and data passes through every node. This makes the network vulnerable to malfunctions. Network technicalities. Sending data in a network requires rules and standards. Sharing these rules, different networks and different devices can talk to each other. A set of rules that conveys data communication is called a protocol. TCP/IP stands for Transmission Control Protocol/Internet Protocol. TCP/IP has become the de facto standard for data transmission over the Internet. Hosts are computer systems that are accessed remotely and hold data or other facilities such as web servers. TCP is concerned with the connection of hosts and not with the nature of data being sent. Packets are collections of data forming parts of a message. A packet contains standard fields such as total length, protocol sender's and receiver's address. IP is concerned with the construction of packets. Packets are sent individually across a network. Packets from a particular message may take different routes according to availability and traffic conditions. They are forwarded from router to router and assembled to form the complete message at the receiving end. This process is called packet switching. A data packet in a network needs an address for delivery. In TCP/IP networks, IP addresses are used, and each computer in the network has one. An IP address is a 32-bit number. Each group of 8 bits is called an octet. The address is quoted in 4 groups of decimal numbers. IP addresses can be permanently allocated to a device, static addressing, or can be allocated as needed, dynamic addressing. A MAC address is a unique number stored in each NIC, and so can be used to identify a device on a network. A MAC address is given as 6 pairs of hexadecimal numbers with colons in between them. Network security. Networks involve the linking of many devices. This is a potential security threat because data might be accessed from many locations. Unauthorized access can result in data loss, theft of data, and installation of malware. To protect against data loss, there needs to be a reliable backup regime. A partial backup is sometimes enough, where the backup is only of dates that has changed since the last backup. Archived data is old data that is no longer in regular use, but is kept in future inquiries and for legal reasons. Many systems have a failover capacity. This means that software detects a potential disaster or abnormality and immediately transfers operations to a duplicate system. Organizations need to have a disaster recovery plan. This is a documented plan which covers what to do in the event of catastrophic data loss. Users are identified by a username and a verified password. You have to authenticate who you are with a password. Users normally have to sign up to an acceptable use policy where they undertake to use facilities responsible. These include not wasting staff time, not corrupting or destroying data, and not installing unauthorized software. The Internet. The Internet is a means of connecting millions of computers and computer networks across the world. These connections are made through a variety of transmission media for the transmission of all sorts of information. The World Wide Web is one of the facilities that make use of the Internet. People use the Internet to view and use web pages via a browser. To connect to the Internet, some specialized hardware is needed. A modem converts between digital and analog signals and allows connection to the Internet. A router connects users' computers to their Internet service provider. A digital subscriber line routers are combined with a modem in order to make use of unused bandwidth in the telephone line, which connects with the Internet links at the telephone exchange switching center. The Internet makes use of IP addressing to identify connected resources. IP addresses are number and hard to remember. The domain name system DNS is a protocol that connects IP addresses to user-friendly names, such as bbc.co.uk. DNS servers maintain databases that match the names against the numbers. When a domain name is entered into a browser, a DNS server is contacted in order to get the correct IP address and then the website required is contacted. A URL is a Uniform Resource Locator, a standard user-friendly way of describing a resource on the internet. HTML is Hypertext Markup Language. This is a way of using text files in order to describe a web page. HTML uses tags to instruct a browser how to interpret and display items on a web page. HTML allows embedding of many elements in a web page, such as table frames and images. XML is Extensible Markup Language. This allows separation of HTML display code and any data that is to be displayed. XML allows users to invent their own tags in order to format data of their own choosing. Cascading Style Sheets (CSS) are files that can be referenced by an HTML in order to apply a desired style of fonts, colors, and other features to a web page. Internet File Standards. JPEG stands for Joint Photographic Experts Group. This is a compressed bitmap image file format commonly used for photographs. GIF stands for Graphics Interchange Format. This is a lossless bitmap image compression standard, but it is only suitable for small images such as logos with limited numbers of colors. PDF stands for Portable Document Format. This is an open standard for exchanging documents. Text and graphics are displayed exactly as in the original, with no need to have the software that created the document. MP3 stands for Moving Pictures Expert Group, Audio Layer 3. This has become the de facto standard for distributing digital music files on the internet. It uses lossy compression to reduce file sizes to about 1/10 of the original. MPEG stands for Moving Pictures Expert Group. This is a set of standards designed to encode/visual information. It uses lossy compression for both the sound and visual components. Various versions of MPEG are used for both digital transmissions, such as via cable and satellite, as well as terrestrial digital channels. Files are compressed before they are put on the internet, so that as much content as possible can be displayed in browsers. Various file standards have become common for documents, image and sound files. Some of these involve compression. This is necessary in order to reduce upload and download times for what might otherwise be very large files. Lossless compression involves storing enough information about a file so that it can later be recreated exactly as it was before. When a lossless compression is uncompressed, it is the same as the original. Lossy compression involves removing some of the data from a file in order to reduce its size. When a lossy compression is uncompressed, it is not the same as the original. Flowcharts. Algorithms are sets of rules that define a solution to a problem. Algorithms can be expressed as a flowchart. Flowcharts use a standard set of shapes to define different actions. An oval denotes the beginning or end of a program. A flow line denotes the direction of logic flow in a program. Parallelograms denote either an input operation or an output operation. Rectangles denote a process to be carried out, and diamonds denote a decision or branch to be made. The program should continue along one of the two routes. Pseudocode. Pseudocode is a structured form of English used to define the steps needed to solve a problem. They can look a bit like this. We intend the instructions between repeat and until to show that this bit is repeated until the condition is met. Programming languages. Software has to be provided to the processor in the form of machine code. This is a stream of binary bit patterns that represent the instructions that are to be carried out. The binary bit patterns are decoded by the processor's logic circuits, and they are then acted upon or executed, one after another. Machine code is a type of low-level code, which means that it works at the level of the computer hardware. Each machine instruction causes the processor to carry out just one operation. Nearly all machine code instructions consist of two parts: an opcode, which tells the processor what to do, and an operand, which tells the processor what to do it to. Assembly language is also low-level language. As with the machine code, each instruction causes just one processor operation. An assembly language uses mnemonics to represent instructions. In the machine code, first group of bits is the opcode, and the remaining digits are the operand. With assembly language, the programmer doesn't have to remember all of these bits. Software called an assembler translates the mnemonics into machine code bit patterns so that the processor need. High-level language do not have the same one-to-one correspondence between commands and machine code instructions as an assembler does. In a high-level language, we can usually multiply two numbers together. In one command, this is not possible at machine level and has to be repeated by addition. High-level commands have to be turned into the binary instructions the machine can understand. This process is called translation. There are two basic ways of translating high-level code to machine code. A compiler converts the whole code onto machine code before running it. An interpreter converts the code one instruction at a time, running each instruction before translating the next. Source code is the code written by the programmer. A compiler translates this source into an object code in machine language. Object code runs independently of the source code in translator. An interpreter does not create object code, and the source code must be translated each time it is run, meaning interpreted languages need the source code and translator present every time the code is run. Integrated development environment. Translators usually include an integrated development environment, IDE, to help programmers. Typical features in an IDE are error diagnostics and debugger, warnings that identify potential problems with the code and listing errors found in the code. Runtime environment allows the developer to run the code during development to check for logical errors. And the translator, compiler or interpreter, compiles or interprets the source code into runnable machine code. Control flow in imperative languages. A sequence is the path through the program that follows a list of instructions carried out in order. For example, a program can ask to input two numbers and output their total. A selection is the path through the program that is described by looking at a condition, then following one set of paths based on the result of that condition. For example, the if, then, else construct allows the program to take one of several paths based on the outcome of a comparison. More complex cases, we may use a case statement or the else-if statement. Iteration is when the program completes a set of instructions several times until a condition is met. To make a program execute a set of commands several times, we can use a count-controlled loop or a condition-controlled loop. In a count-controlled loop, we use an indexed value to tell the program how many times to complete the loop. In a condition-controlled loop, we tell the program to either stop executing the commands when the condition is reached or to execute the commands while a condition is true. Repeat until executes the code that follows while a condition is true. While executes the code that follows while a condition is. Data types: real, boolean, integer, string, character. Real is a number. Boolean is a statement, true or false. Integer is a number, but this time it is a whole number. String is a word, and character is a letter. Variables and constants. A variable or constant is a named storage space reserved in memory to store the value associated with that variable, name, or constant. Variables and constants are often declared at the start of a program to avoid the danger of any data already stored in that location by a previous program being used and giving false results. Variables and constants should be given meaningful names in order to make it clear what they represent and to make code easier to follow. Operations. There are several standard mathematical operations that a computer can perform. The results are usually assigned to a variable. The assignment operator may be equal or may be double equal or colon equal or colon double equal, but these all mean the same thing. The result from the right hand side is to be stored in the variable on the left hand side. Operators. Comparison operators. Comparison operators are used to compare two values. Equals means equal to. Greater than is greater than. Less than is less than. Greater than and less than is not equal to. Greater than equals is greater than or equal to. And less than equal is less than or equal to. True or false are redundant depending on the values being compared. Comparisons are also frequently used with and, or, and not logic operators. Operator priority. The order in which operators are applied can be important. The priority for operations is: operations inside brackets are dealt with first, unordinary operations such as the minus sign and not, multiplication and division, addition and subtraction, Boolean operators such as and or. Arrays. Variables should be given meaningful names to make it clear what they represent. If we need a number of variables all the same name, then we can use an array. An array is a set of variables with the same name or identifier and an index number to identify the different variables. For example, a set of names for 20 people could be stored in the array name using name 1, name 2, and all the way to 20 people. Testing. Good program design and the use of any IDE will eliminate many errors from a program. Syntax errors are errors in the use of the language rules, and these are often identified by the IDE. Examples of syntax errors include variables not being declared before use, assignment being used incorrectly, and variable names incorrect. Logic errors may be generated by variables not taking the values expected or decisions that do not allow the program to complete. Causes of logic errors include conditions that cannot be met in conditional statements, infinite loss, and incorrect algorithms. This could lead to errors such as division by error, 0, programs that do not complete, and incorrect outputs. And that's why. That was the longest video I've ever done. I hope this video helped, and in the meantime, good luck with your exams.